Hello, everyone, and welcome to the Humans and Wildlife Show. My name is Georgia Autere. With me, as always, is my co-host, Christian Sase. Christian, what are we going to talk about today? Oh, I can't hear you. What happened to your sound?
Okay, I muted myself.
Aha.
Thank you. Okay, hi everyone, and welcome to another show with Georgia and myself. So I'm Christian Sasse. So, last week we were talking about what happens when things get too hot, and now we talk about animals and also humans. What happens when it gets too cold? So it's quite an interesting topic.
Yeah, and one of the things that inspired this week's topic is that I had a paper come out, I think it was just yesterday. There it is. So I had this paper come out about just a perspective piece, sort of talking about how we as scientists should be studying animals' adaptations to the cold. And so I sort of proposed this conceptual framework for collectively thinking about like all the strategies that animals use to deal with cold environments, especially freezing temperatures. And Christian, why are freezing temperatures so difficult for animals and people?
Well, before I'm going to throw the question back to you, Georgia.
Uh-oh.
What do you actually prefer? You're very much an outdoor person. Do you prefer, if you had to choose and you have no choice, would you rather have extreme heat, let's say for a week, where you just have extreme heat or extreme cold, and you have to deal with it? Which one would you choose? And you have to choose one, and why?
Yeah, this you're asking me this knowing that I just came back from 4 or 5 days in the desert.
Exactly.
But even with that experience just right on my heels, right behind me, I would have to say I'd prefer the heat to the cold.
Interesting. I would say the same. And why is that? Why is that?
I don't know. I think when I feel too hot, I just feel like it's fine to just sort of like lay back and be like, oh, well, I'm hot. I guess it's an excuse to be lazy and just sit around and eat ice cream. Whereas if I'm too cold, I just feel like a little bit more like physically in pain and uptight no matter what I do. I don't know. Why do you prefer the heat?
Because I'm scared of the night, honestly.
What?
I thought about, yes, the night. To freeze at night is horrible. At least in the desert, it cools down at night. Um, and that gives me some rest. So it's as simple as that, right? It's both are extreme, but if I couldn't sleep, I would have a phobia of not being able to sleep because it's just too cold, and then not being able to deal with it. With the heat, I think, well, at least that there's probably a better way of dealing with it, but maybe I'm wrong. It's just what I'm thinking, right?
I
So
am learning a lot about you. I feel like this is some very like morbid, deep fears. You're like, I'm afraid of the night, freezing to death. Intense.
oh, have you ever been cold at night? I have. It's lovely.
Yeah, yeah. Well, but still, I don't know. So I'm trying to make
Okay.
sense with this window. The sizing is being obnoxious.
Anyway, hi everyone, and welcome. Tell us what you prefer, too hot or too cold,
Yeah,
and put your comments in.
yeah. Tell us. We want to know. Um, I I'm trying to think. And you know what? As I was in the desert, so one of the places I went was Zion National Park, which is one of our national parks here in the United States. It's very beautiful, and there was this little kid hiking by on the trail,
Mhm.
and he was with his parents, and he was complaining that he was too hot, and he was like, "I hate the heat. I love the cold."
Wow.
And his parents were like, "Oh, really?" And he was like, "Yeah, I love being cold." And they were like, "You didn't think that until you got too hot, though." And he was like, "No." But I mean, and I think to some degree, we're all that little kid who just we I don't know, we want whatever the opposite is. If we're too
Whatever you're
hot,
thinking,
we
the
want to be
glass
cold.
always cleaner.
Yeah,
Yeah.
vice versa.
So Candace is saying too hot. Yes.
Yeah,
Gentleman Ghosts also there. What do you prefer, Gentleman Ghost? Tell us.
yeah.
Mary and all others. Definitely better hot. I think remembering. Yeah, isn't that funny? Isn't that funny? Yes, yes. stays the same. Yeah.
See, you all really took this to an extreme. I was just like, what's physically the least comfortable for me, or the most, more comfortable. And then you and Gentleman Ghost Christian, you just bring it straight to death, to freezing to death at night, to which one are you more likely to die from? I'm like, oh my goodness. But you know what? This is segueing into our topic very nicely, because I do feel like I get too hot or too cold very easily. Someone this weekend was telling me, they're like, yeah, you're like Goldilocks with your temperature. And there's a reason for that. Why, Christian, can you imagine why I might be more sensitive to the external temperatures than you might be, for example?
I don't know exactly why, but I read in general, my feeling is that women are more sensitive. Look, I don't know if this is sexist, so I'm not trying to imply that, but I just read that. So,
Well, so there's a couple of reasons
mhm,
why that might actually be true, though, right?
mhm.
And specifically, so one is has to do with circulation and blood flow patterns. Um, and two has to do with size. There's, size differences between men and
Okay,
women.
okay.
Um, yeah, do you want to expound upon that, or do you see where I'm going with that?
Yeah, of course. I mean, that's the volume to surface area ratio. I mean, it's best explained on a hummingbird and an eagle behind me, right? A hummingbird has a huge surface area and is quite light if you put it on a scale, right? In relation.
A huge surface area relative to its body
Yes,
ratio, right?
yes,
And yeah, you can do the math on this, everybody, if you want
yes.
to. If you're feeling so inclined to do some math for fun,
And then you are
you could
also
see with a little cube. Yeah, if you have like a 1 inch cube,
yes,
each side, like what's the surface area collectively, and then what's the volume of the cube, and you
that's it.
will see that a 1 inch cube, like a 1 inch sides versus 3 inch sides, etc. The higher you go, um, proportionally more of the cube is on the outside touching the surface when it's bigger. Or
That's
sorry,
true.
proportionally
That's correct.
less
Well,
is,
with
yeah.
one over r, you can do the math in your head. 4 pi r squared divided by 4/3 pi r cubed. That's the volume of a sphere, surface area of a sphere, and it goes proportion to 1/r. So the larger you get, that's how much it's shrinking. So okay.
Yeah, the bigger the cube, the relatively more of the cube is
Cube,
protected, is
cube is
insulated inside the cube. Yeah.
1/r.
And so my mom said that she once told me, she's like, yeah, at the hospital we call this little girl syndrome, where like it's the small woman especially, where they come in and they have hypothermia, or they have heat exhaustion, the opposite. They're just sensitive to the external temperatures more so, because you're more of your surface, or more of your outside is exposed to the environment.
And
Um,
and, and 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 I mean, we're very very lucky. We can go indoors when it gets too hot or too cold, but animals can't do it. And let's jump into your topic now, because that's where it gets really interesting. Your paper. So, by the way, it's a marvelous paper. I read it today. So, and it actually reads very well. So, congratulations, first of all, on that. You wrote it all yourself. You're the sole author there, which is marvelous.
yeah, you're like, oh, it actually reads very well. That's nice to hear, though, because I did once get a comment from a reviewer that the first author, which in this case was me, the
Mhm.
first author should get a book on how to write. And I was like, well, I think I'm a pretty good writer, but I will admit that that particular paper I didn't do a great job on. Sometimes there's a lot of cooks in the kitchen, you know what I mean?
Yeah, but but uh,
Sometimes
but
it's easier to just write it yourself.
but academics can be very nasty to each other. It's a strange world, right? So
Yeah, well, if you can't take the heat, get out of the kitchen. Right on theme. Um, no, but people should be nice to each other in
very sure.
academia and elsewhere, I think, to be clear. But yeah, so this paper, it came out yesterday. And yeah, I mentioned briefly it's about, thinking more holistically about how animals deal with the cold. And sort of part of what inspired me to write this is, as scientists, we often say, like, oh, well, animals that migrate might be particularly sensitive to climate change because it will disrupt, the timing of their migratory
Hmm.
events, and it might cause migratory mismatches, where the that because of global warming and like temperatures shifting at different rates, or for example, like maybe the animal migrates, but then its food, the insects haven't come yet, and so it migrates, and then there's nothing to eat when it gets there. So we as scientists have sort of collectively been saying like, oh, migratory species might be especially sensitive to climate change. Well, species that like polar bears that are adapted to actually live and survive in the cold, but they might also be especially sensitive to climate change because, you know, they need the cold temperatures as part of their cycle. And so one of the things that I wanted to say with this was, look, we as scientists, we can't always only say, well, we're going to study this group of migratory animals. They might be especially sensitive. We're going to study this other group of animals. They might be especially sensitive. At some point, we have to take a step back and consider sort of collectively across the board, figure out some way to compare apples to oranges. Like, do we see that migratory species actually are more sensitive than you know, these cold adapted species? So that was one inspiration behind it. Yeah.
So what you're saying basically in the paper is that there are three main ways, you call them strategies, of dealing with cold, isn't there?
Oh yeah.
That's maybe you just have to explain that quickly.
Yeah. So the three, and to
Mhm.
some degree, why does it do this? To some degree, the three main strategies, the point is just that I hope people can see that kind of.
Yeah, I think it's okay. Yes.
Okay. Yeah, I mean, to some degree,
Mhm.
the important part is to create a framework so that you can compare apples to oranges. And so, you know, even though migration, torpor, cold resistance, very different from each other, but if we start saying like, okay, we're going to try to measure these and compare them, then we can like maybe get at some of these broader patterns. So like specifically, okay, here they are. Seasonal migration.
Mhm.
Or more generally, you can think of this as avoiding the cold. You're like, I'm just going to leave for the winter and then I'll come back. Some people do this, snowbirds, right? We go down to Florida or the southern US for the winter where it's warmer, and then we come back when it's nicer. But a lot of animals do this. They must do this to survive. Another one of the axes is torpor, which an extreme form of torpor is hibernation, which is just you let your body get cold. You drop your body temperature, and you sort of go into a slowed metabolic state usually as well alongside that. So there's two of the axes: avoiding the cold, letting yourself get cold. And then the third one, cold resistance, maintaining activity despite the cold. So this is like the polar bear, for example. It's eating a lot of like seals and meat during the winter. It's using its warm bloodedness to maintain a high body temperature. They're burning calories, you know, energy to stay warm despite the cold temperatures around it, and that allows it to like maintain activity during the cold temperatures. Yeah. Does that make sense, Christian?
Yes, I think it makes complete sense. I was actually thinking about the polar bear because it's such such an interesting
He's the polar
um,
bear.
way it deals with with heat. What is very interesting about the polar bear is that it's actually white. I mean, it's unusual, right? It's very interesting, and from heat absorption, what they found out again, the polar bear is incredible because underneath its very white fur, it's actually very black. So what happens is light scatters in. It's incredibly efficient heat absorber. So light scatters in, multiple scattering into and gets absorbed by the very black skin, and thereby is much more effective than a brown bear, black bear, or anything else. So polar bears have figured it out.
Yeah, right. So it brings me to a really good point, is that like each of these axes, as I propose, it's not just about, there's not just one way to measure it. Like
Mhm.
you could measure how resistant to you are to the cold. It includes things like how much food energy do you have access to in the winter so that you can like burn calories to stay warm metabolically. How well insulated are you? Like how much fat can you put on? How furry are you? You know,
Exactly.
what's the color of your skin, your fur, things like that. um yeah, so all of these can contribute to each other, and in the paper I talk about some examples when species can actually, well, I guess another point of the paper is that species often use multiples of these axes. Species often, in reality, they aren't just migratory, they aren't just hibernatory. They do some combinations of things. So one of the examples is the chipmunk.
Okay, that's interesting. Yeah.
Oops. Yeah. Do you remember quiz time? Do you remember reading about the chipmunk?
Yes.
I think I can actually. I'll just show on the picture, kind of.
Yeah.
So the chipmunk, they'll often use like torpor in the winter, like they'll go into a hibernation, but they will also stockpile food, like they'll store a bunch of food in their den or whatever. And so some researchers, what they did is they basically gave the chipmunks supplementary food, so they had access to more food than they would normally in the winter. And what they saw is, okay, like maybe the chipmunk was over here using hibernation and eating some food in the winter, but when they had access to extra food, they shifted to be more over here, where they ate more food and they didn't use the torpor, they didn't use hibernation as much. So this framework that I'm proposing, I think, has really interesting suggestions for like hypotheses we can test for like how much can species move along around in this sort of parameter space and stuff like that.
Yes, and I, it's so good you bring this up, because what you're suggesting, how important it is to consider all these combinations. And nature's complex. I mean, they figured it out for millions of years, right? And here we come studying nature, and you said it, and you know what? We're looking at these isolated things, and that often makes us look at things very narrow, and I'm very guilty of that myself, because it's just the way we function. We're analytical, we look at one thing and then we think we've understood it, but actually we haven't understood things at all.
Yeah, and like I think a lot of it, I think it's important to get back to just like being a kid sometimes. Like you can look at like little like kids books on like how do animals survive the winter, and it has, oh well, there's migration and there's hibernation and there's like eating food and stuff. And I think as you get older and you get serious and start researching, you get like more and more specialized. But I think it is important to take a step back and just have that sort of child's perspective again of like the whole world and how interesting it is and how it all fits together. So that's one of the things that also inspired me to write this. Gentleman Ghost says, interesting. So if food is plentiful in winter, hibernating animals will eventually no longer hibernate. So potentially for some animals, but potentially not. So we call that plasticity, like how much flexibility is there in an animal's behaviors or responses. And so in the example with the chipmunk, yes, the chipmunk did switch its behavior based on how plentiful food was. It has a plastic response. So it might be better able to sort of deal with environmental changes with global warming or altered food resources or whatever. But not every animal will necessarily have that response.
Yeah, Georgia, that's such an interesting idea here, because if you talk about this I can't even say the plasticity. Whatever.
Flexibility, we can just say, yeah.
Okay, right, the flexibility. I mean, is that due to maybe evolution? Because there was a lot of climate change, of course, through the millennia and so on. Is it possible that this is some deep instinct that is still in the animal to be able to be flexible to it? So that brings up the second question, maybe just a Gentleman Ghost's point of view. Is it possible that that we will see unexpected behaviors as climate change comes up, that we haven't expected, just because it is inherently somewhere in the animal?
Yeah, I mean, I think for some animals that's certainly possible, right? But the kind of crux of the situation is that animals rely on each other. They're part of an ecosystem. So what happens when you have some animals shifting and other animals not shifting? Maybe the prey species, like maybe one animal like shifts, but then the animal that relies on that animal for food like can't shift along with it. And so then it's sort of doubly negatively affected. It's lost its food resource.
There
it's
you are.
suffering from climate change affects.
That,
Yeah,
yes. So it's much more complex as usual. Yes.
there's the old joke that
Yeah.
like scientists like to have that be their answer to everything, which is true. Yeah, so, and oh yeah, I did want to highlight briefly this article that Amanda Price sent, which is gosh, I need to find a way to deal with the screen better. But there is this record basically of a bat.
1,500.
Tiny bat makes record shattering flight with 1,500-mile migration. So yeah, a bat that weighs less than an ounce, a type of pipistrelle, was recently documented flying from Russia to the French Alps. So this bat can migrate. This is an example of a bat migrating pretty far. And basically, like, I think, when we start, I think measuring more individuals, like, and seeing, like, is there enough individual variation that we can see, like, within a species, like, oh, the species, if you were to plot all the individuals on this graph, they might fall, like, in this range or something, like where populations farther north migrate longer and populations farther south, like, migrate shorter distances. Yeah. Yeah. This is a very long comment, so I'm just going to read it. Jill Maurer says, axis tilts, population, ice ages, climate changes, industrial pollution, and climate change. Even though some of this we do know, your intellect brings much to ponder. Oh, thank you. Unbelievable how you are both promoting deep thought and study. Thank you. Well, thank you very much for that, Jill. It's a very nice comment.
That's very kind. That's also why I'm here, because it's so thought-provoking all the time.
Yeah.
It is.
Christian, yeah, speaking of, you had some interesting thoughts on what this cold resistance axis really, how do animals achieve that, right? From a physics standpoint, like we talked a little bit about, like the polar bears has insulating fur.
Yes.
It has like a big sort of brown protected body, relatively speaking.
Yes.
It has short limbs, so like less
Correct.
likely to get frostbite because you don't have you're not like getting as far away from your heated core.
And that brings me to the most fascinating. I mean, I remember especially when I was in Finland. Ice fishing actually was really an interesting experience. I mean, the way the Finns keep warm is with vodka. By the way, I don't know that's a perfect solution, but that's what they do.
So that is alcohol makes you feel warm, but it actually makes you more susceptible to hypothermia. Because I think it causes your blood vessels to like constrict, especially in your extremities. So you actually get more prone to like frostbite and things like that. Even though I forget why you feel warmer, but it does make you more prone to.
It's probably all to do with the brain. You just think you're warmer, of course, but it's funny. I just had to bring that as a joke. That wasn't what I was getting at. Okay, but it's true. They do have a bottle of vodka, and then they go ice fishing. Anyway, me who had no idea about ice fishing, by the way, I was the lucky one. Okay, I was the one who caught the fish. I don't know how I did it, but it was one of these funny. It's just a joke. Anyway, what fascinated me, of course, were the animals there, the birds, and so you see ducks and all kinds of winter animals, and I just think, how do they do this on the cold? I'm freezing like crazy. I was dressed up like an Eskimo, and I was still really cold, especially like you say, my limbs and so on. And then I looked at this, of course, and again, nature did a brilliant invention here of heat exchange. Right, it's in the system. So basically, the way it works with their feet. I mean, ducks need huge feet so that they can swim effectively in water, right? But that's actually not very effective when it comes to cold, because we're just talking about surface area. They got this huge surface area of their feet, and that doesn't make sense because they must be losing heat like crazy, because heat always travels from hot to cold. Always from hot to cold. Always, that's a law of thermodynamics. It always happens. So my goodness, they must be losing lots. How do they do it? Why don't they just die? And the reason is amazing. What nature has come up with there is they have an inbuilt counterflow heat exchanger. So their blood, of course, flows through the arteries into their into their feet, right? And at the same time, the veins takes it back again, and they are so interwoven. They call this rete mirabile or whatever, but that's a Latin word. But it basically means it's a wonderful net, right? It's a wonderful exchangeable heat exchanger. So what happens is, as the blood flows down through their legs, the temperature it exchanges with the cold flow that comes from the feet, and the temperature actually gradually goes down. Can you imagine? They usually would have a typical bird temperature would be 100 Fahrenheit or 40 degrees Celsius or so, or even higher. It's higher than ours. But as they get to to their feet, the temperature goes down more and more as the warmer blood flows down. It gives off heat to the colder one coming up, and it by the time though it reaches the feet, it's really cold, but just enough that they don't get frostbites. And they can also apparently regulate the flow, which is insane. Go
So
on.
yeah, so you're saying, just to make sure I'm clear, that like the heat. Okay, wait. I think that we should come up with a more professional way to do this, but I'm going to try to make a drawing right here.
Yeah,
So,
I can bring in a
oh,
diagram.
I'm drawing. I got my red.
Oh,
I got some pens.
you're gonna draw. That's great.
I'm going to draw.
Okay,
So
you draw.
duck foot.
Okay, here we go. Yes. Oh, that's your duck foot. Wow,
Yeah.
nice. You're good.
Duck foot. Thank you. Thank you. And I'm doing this in like the mirrored camera view. It's under the
Amazing.
water.
Look at that. Look at that. Yes.
Ha ha ha. Okay, it's under the water. And so the problem is, of course, if you're in the water for very long,
That's
you
it.
get cold. We know
Yes.
this. As you described, you're losing heat, and water has high heat capacity and whatever. Okay, so you're saying like the bad thing that could happen is that you have this warm duck foot, and then it loses all this heat into
That's
the water.
correct.
But let's see if this is correct. But you say, okay, they have.
The warm blood is coming through the arteries, right? Down.
So it's
Okay,
coming, yeah, here comes the warm blood from the arteries in the heart.
Yeah.
And it's going to go, the flow of blood is going to be, I'll do it with a pencil. The flow of blood, as you know, it goes down
That's
into
it.
the foot.
Yeah, a foot.
And
there
then
it's
it
really
comes
cold.
back up,
And then it comes back
it
up,
becomes
yes.
deoxygenated, and then it has to go back
Correct.
to the heart to get, and then to the lungs to get oxygenated
Through
again.
the veins. Through
Yeah.
the veins. Yes, that's correct. Exactly.
Yeah, so we have this warm blood coming down, but it's also very close to this blood that got cold from being in the
That's
foot.
coming. Yeah, they're all
It's
interwoven.
coming back.
They're interwoven. Exactly.
Yeah. And so instead of only this happening, where you're losing heat to the environment and getting very
Which would
cold,
be tremendous.
some of the heat goes back over here and warms up this
That's
blood,
correct.
this
That's
cold
correct.
blood. And so then you just have like medium
it goes up the leg too, it comes up all the way. So it's the heat exchanger is coming down all the way through the leg into the foot, actually. So that there's a temperature gradient all the way down. It's not just down there, right?
Do you want to share that? Do you have a picture to share?
Yeah, I do.
We can quiz how
I do.
How well I did.
Oh, you did very well.
I think this should become a regular part of the show. You should describe something, or vice versa.
You draw, because I can't draw. Okay.
And it's like charades or shenanigans or something. And
Can
I
you
try to
see
draw.
my screen? I don't know. Did I share it? Wait,
I don't see that you've shared.
Let me try now. Unable to share screen. Please update. Oh, come on.
Oh, that's stupid. Here, send me the link in the chat. If you
Okay. Okay. Yeah, I put this all into my notes. 1 second, George. I can't believe it.
And as Christian's pulling that up, I have a question for the audience. What axes of this chart do you think humans use, and how? So we just talked about the duck foot, and that's part of, I would argue that's part of cold resistance, like being able to keep your feet, or that's reducing how much heat you're losing to the environment, which is helping you conserve like the energy that you're producing in your body and stuff. So I'd say that's part of the resistance axis. Yeah.
Oh,
Gentleman Ghost says that, Pictionary part. And mountaineers can use this in their extremities. So we can't unfortunately change the makeup of our arteries and blood vessels and veins and stuff. But veins and arteries are part of blood vessels. But what we can do is this, and this is what mountaineers do for their feet, is put on boots. So we increase the insulation of our feet.
That's what we do, yes.
And we wear coats, sweaters, things like that. So I'd say that's increasing our. Well, I don't know if that may be more like cold avoidance, right? You're less like.
Oh, that's resistance. Yeah, that's right.
I'd say it's like resistance. Yeah.
I gave you the link in
Yes, I saw. I'm too busy being full of myself. So Christian sent me this link. Let's see. Here's the show, everybody.
That's not the diagram I wanted, but it should be just as good. Yes, it's just as good. So there, you see how it's interwoven, very clever, right?
Oh, I see. Yeah, so it's not. I was kind of right, but I wasn't quite there. It was, as you say, it's not just that it's
so clever. Nature is so clever. It gradually goes down the leg, right? It's so the temperature goes up. By the time the blood reaches the foot, it's already very low. That's the whole point. That's why it's not losing in such a large surface area so much heat, because the temperature is already so low. It's clever.
Very informative. Yeah.
It's.
Pat Davis says each week topics are so informative. Good. I'm glad they make sense to at least partial sense to people. I don't think the two of you will ever run out of subjects to ponder. I certainly hope not. Thank you for the weekly series and your time. Much appreciated. Well, thank you, Pat. Your comment is much appreciated as well. And then Pat has a comment to my question: which of the axes do people use? Pat says, I think that I might have to read this off of the chat. Cannot deal with the cold due to limitations due to short daylight hours, more physically uncomfortable. Fear of pipe and home damage. Yeah, not just physical issues, more to worry about. Thanks again from Pennsylvania. Yeah, so Pat brings up a number of things there. Mm-hmm. And one of the things is the fact that we live in homes, right? So I would say living in houses is kind of like again, it depends, like, are you measuring this? We've in our house, we've basically created a warm microclimate, right, by burning fossil fuels. And I would say that's part of like cold resistance, which here it's migration. Yes. But I do say somewhere like later in the paper, like, if you think about this axis sort of more broadly, cold avoidance. Yeah, because we're creating this warm area around us. And then, polar bears, if you put on a lot of fat, I'd say that's cold resistance. But like once you're insulating yourself like outside of your body a lot, I think it's arguable whether it's resistance or creating a warm microclimate, cold avoidance. Does that make sense? Am I losing people now? Other scientists I talked to, I did talk about other people. I did talk to other scientists about this paper, even though I'm the sole author. And everyone's kind of like, oh yeah, that's cool. And then they kind of get a headache, and then we talk about something else. Jill says barriers to hold heat in. Yeah. Insulation. Christian, were you going to say something?
Yeah, I'm just trying to. Sorry, yes. I was actually. Last week we were talking about heat exchange and how wonderful trees actually are. Remember that one, and this time I wanted to bring up another topic because it does bring me a little bit to the topic of the way ducks work and or animals with heat exchanger built in, and the way we are learning also from nature to use heat exchangers much more, because you were talking about burning fossil fuels. And there are more efficient ways now that we're learning, and one of them is the heat pump, right? And I just briefly wanted to talk about the heat pump because it's been quite interesting.
Tell me about the heat pump, Christian. This is something that like I associate it with like nerdy engineer types are like, heat pumps are so amazing. And I'm like, what's a heat pump again?
Okay, so So yeah, I'm so upset because I'm trying to share my screen. I've got all these beautiful
Oh
diagrams,
no.
so this is really what's upsetting me. I'm on an Apple. This is the problem when you have them. So
Try again real quick. I
I'm going to
stopped
just, I have
sharing.
to go to system preferences to give, I'm just sorry. I'm just trying to see
Mhm.
why it's not permitting me at the moment. It's always the same thing. I apologize for that. I didn't know that I was going to run into this problem. Why
Hi,
are you,
Sean.
one second, I'm just going to try quickly, see if I can make, I have to authenticate, you have to give permissions for everything here. One second. Let me,
Someday we're gonna get our streaming just like we're gonna get it
yeah,
figured.
no, I'm sorry
We
about that.
are, and while Christian's messing with that, I will plug we are actually paying for this service now. Blah, to be able to stream simultaneously to like Facebook and YouTube and stuff like that. So it's I don't know. Someday we'll figure out a way to get donations maybe or something to try to get support for that. But for now, we just do it. Did something happen to Christian's Dell computer? I don't know. Dude, gotta get a
No,
Dell
no,
or whatever those ads used to say.
no, nothing happened to my Dell computer. It's only in the summer house because when I'm here,
Mhm.
I use the main Mac, which is very nice. It's got a great screen. So this is more my studio. That's the reason. It's
Yeah,
great. It's amazing that you
Kristen,
remember that.
your summer house, again, you are highlighting my point that people do these things too. That's your summer house. You migrate to your summer
That's it.
house.
That's it. That's exactly right. Yeah,
Yeah. So we
that's
migrate, and avoid the cold. We
we
definitely have
do.
some cold resistance going on. I mean, I would argue that in Christian, you keep doing what you need to do. Keep messing around with your
Yeah,
computer. I'm just
give me a few
babbling to
more.
buy you time.
Yeah, give me a few more minutes. It's such a
Yeah.
pity because I prepared this so nicely, and now I'm upset that I cannot.
Yeah, you
Here.
just find it. You focus on finding it. I'll focus on
Okay.
babbling.
Okay, you
Um,
go on babbling. That's great.
yeah, thank you.
So I'll try.
Um, yeah, it's just I about lost my babbling train of thought, but yeah, I think just highlighting that people. I think we definitely use migration. At least in some individuals, migrate. They stay at the comfortable temperatures or they avoid the cold. And we have oh yeah for like the cold resistance. I mean, I would argue like any like warm-blooded animal, like mammals, birds, to a large degree, we burn calories, we burn energy to keep our bodies warm. There's a saying, and that helps us, that helps our cells not freeze, like that helps the water in our bodies not freeze when we're outside in the middle of winter and something like that. So that's cold resistance. That's maintaining our activities, our bodily functions despite the cold. And I would say we do not really use torpor. Our body temperatures are pretty fixed. If you get, just a few degrees Celsius below your whatever your individual like normal body temperature is, you start risking hypothermia. So torpor is specifically the ability to have a lower body temperature with no pathological side effects. No like basically bodily injury, disease, unhealthiness. Um, yeah, sure. Kenneth asks, I'm new to the channel. Can you please tell me what it is we're talking about? Just trying to catch up. Yeah, so we're talking about different ways that animals survive cold temperatures, especially, you know, humans, animals, all of biological life has, has like water. We have water in our bodies. And so you start dealing with freezing temperatures, and it's very challenging for life. You can't have, the water in your cells freezing and then exploding your cells and stuff. So this week we're talking about how animals deal with cold temperatures and also how people, deal with cold temperatures. And it's inspired by a paper I had that just came out yesterday, which is basically about how, like, as in my field, biologists, we should be thinking more broadly about looking across animals and trying to come up with some big picture collective synthesis, patterns, observations about like the trade-offs between these different strategies that animals use for dealing with the cold. Yeah. The comment, I love how the eagle behind Christian looks like he's popping out of his head. Yeah, the eagle always gets some good comments. Looks like he's sitting on Christian's shoulder like a pirate. And another comment from Susanna, then I guess the Nordics migrate some 50 times a year as they keep hitting the road heading to their summer cottages as soon as it's Friday 1601. Yeah, that's kind of a migration, a for fun migration. Yeah, I think like in its broadest sense, migration is any like back and forth movement. And there's certainly other species that have like daily, or in this case weekly, migrations. So plankton in the ocean, these like tiny little small organisms in the ocean waters, they have daily migrations based on the sunlight, basically. I forget exactly what it is, but I think like when it's sunnier, then they like come up to the surface of the water so they can get more sunlight. And then for some reason at nighttime they go down. I don't remember why. Maybe there's like more oxygen down lower or something like that. Gentleman Ghost says, off topic, HAPS closes today. Don't know if it's too late to redeem money, but FYI. Yes, thank you for the update, Gentleman Ghost. So HAPS is a platform that we used to use to stream to multiple platforms at once, to Facebook, to YouTube, to Twitter, but it's ending today. Christian and I kind of, I think, both abandoned it quite a bit ago. And for those of you just joining, Christian is experiencing some technical difficulties, which he seems to have resolved by just deciding to send me a link.
Yeah. So what I've done now is I'm sorry. I'll have to. I didn't even know this problem existed that I can't. But if you scroll down, there's a picture. That's what I'm going to go, and I'll explain a little bit what a heat pump is. Okay. Yeah, if you see that diagram there, that's great.
Christian, can you try to let us, like, what is like the broadest?
Yeah, the broad part is very simple. It's really simple. It's a reverse air condition. It's an air conditioner that works both ways. Okay, so we both know an air condition. First of all, how does an air condition? What does it really do? It doesn't cool the air. What many people believe. Of course, it cools the room. The temperature goes down. But what it does, it transports the warm air outside. That's the principle of an air conditioner. And if you reverse that, you get what you call a heat pump. Because now, you won't believe it, it can be ice cold outside, but even if it's ice cold outside, there's a lot of heat capacity in the air. That's what many people believe, and we can actually extract that. It's amazing, but we can extract the heat from the cold, and it can be sub-zero temperatures, and bring that into the house, right? And that's basically what we're doing. It's a reverse air condition.
So are you separating the air? What do you mean when you say you separate the hot from the cold?
No, I'm not separating the hot. The air always goes from hot to cold, always from hot to cold. That's the principle that all air conditions use, right? So an air condition really works on the thing that in order to get the heat out, we need to reduce the temperature on a surface to draw the heat in there, right? That's the first thing. That's the principle. And how do they do it? They do it by expansion. If you've ever seen this spray, these bottles, these bottles that you spray and it feels sort of cold, that's because through a nozzle, when air expands, it has to, in order to expand, has to extract heat from the surrounding, thereby cooling it. That's the principle of refrigeration. That's it. It's really simple. And reversely, if you take air and you compress it, it heats. You can get air to ignite if you compress it. So those are the two things that an air conditioner builds on, and the rest is just refrigeration and some fancy tricks. But that's how it works. So they expand air through a nozzle, get down the temperature. It draws the hot air in. It then is brought through. You have to increase the temperature to get it out in an air conditioner. So you compress it again. in order to heat it up, it has to be warmer than the surrounding, and you expel it to the surrounding, and that takes some energy. That's the principle of an air conditioner. Now you can reverse the whole process. You can reverse the whole process in winter, and that's the wonderful thing. You're now, what people won't believe, you're taking heat from the very cold environment. How do you do it? By creating a surface that's even colder than the outside, right? So again,
so counterintuitive. Yeah.
I know it's so crazy, but you have to make a surface outside that's colder than the environment. Then suddenly the environment is hot, and the hot air says, "Oh, it's colder there. Let's go there." Okay, that's very sloppy physics explanation, but I'm
Okay.
just saying,
I think I'm understanding. So
and
ambient air, this is you're taking in air from the
that's it.
outside.
From the outside, and it's warmer actually. And then I have some refrigeration process. Don't worry about all that. But basically,
We make the air
I'm bringing
cold.
the energy inside, warming it up a bit, and expanding it. And that is more efficient than if I use a furnace and burn fossil fuels. That's the main argument. And also because you can reverse the process for winter and summer, which is really neat. Okay.
So the same system can cool or heat.
Or heat. That's the thing. So it's similar to an air condition in summer, but it's exactly the reverse in winter.
If
And
I hear like a mini split, is that a type of heat pump or no? Do you know what I'm
sorry,
talking
what?
about? A mini split, is that a type of heat pump?
I don't know what that is. Sorry.
I will Google. I'm just trying to think of like more words that people might know this by. Yeah, so if I Google mini split heat pumps, I mean,
Okay.
then it comes up like yeah.
So you can do the same with a lake, by the way. In Sweden, that was very popular already when I lived in Sweden.
Yeah. Like
Is
are
it's
these
not
kind
the only way of extracting heat. I mean, it's much more efficient to extract heat from a lake because the temperature of a lake is much warmer than the surrounding usually. So you can do exactly the same in the ground. You can have a ground-based heat exchanger under the house where you just extract the heat from the earth. Okay. Hi, Amanda.
Hi. Yeah. We have a question, compression. Yeah, I similarly am confused about how this air compressing and expanding is
Look.
happening.
That the only thing you have to remember is if you want to heat up air, you compress it. Okay, you have to compress it. It takes energy. If you want to cool air, you expand it. So you decrease the pressure. You first have higher pressure, and then through a nozzle it decreases. And have you ever tried that? If you take a spray can, it really feels cool. That's because it's expanding. That's the only thing. Compression, heating, expanding, dropping temperature. That's how they all work, right?
And
That's
this is all part of our cold avoid how we avoid cold as humans. Yeah.
that's
And so
how
I
that
need to bring it back to how we tie in with other animals. We have this comment from Kenneth Wilson. Okay, thank you. Now the birds of Alaska can withstand the cold, but other animals such as snakes can't handle that type of environment. Yeah, so a snake exposed to cold temperatures, a big part of what it's going to do is use this torpor axis. It's relatively limited to that probably because it's an ectotherm. They have some ability to control their internal body temperature. They can choose to be in a sunnier spot or a cooler spot, but to some degree, it can drop its body temperature. But there's limitations on that, right? It doesn't want to let its body freeze solid. Like that would, water expands when it's frozen, and then the water would expand and damage the cells and stuff. So you're exactly right that we sort of see a lot of northern limits on reptile species, for example, because they can't very often handle these cold temperatures. Yeah. And so I keep tooting my own horn, but one of the things that I think is cool about this framework is, we can use it to collectively maybe better understand things like species range limits, or why is it that we have so many more species in the tropics than higher latitude areas? Like, do you start to see, these torpor users becoming less and less species that use that towards the tropics, that dropping off, like torpor use dropping off relatively faster than migration use or something like that as you get towards the poles. So I have all
Did you,
kinds.
did you see Susanna's comment, by the way?
I think I missed it. Oh
Then
yeah. I talked about it when you were
Oh, you did. Sorry, you
when
did.
you were yeah, no, it's okay. You were
Okay, good,
busy.
good.
You
Okay,
were
good.
busy
Okay,
dealing with your
good.
computer
Yeah, well, that's
problems.
a stupid problem. Yes.
Susan, yeah, thank you for helping me with my babbling, with my stalling. Um, yeah. So, and then I mean, part of also why we did this topic is Christian. You found this other cool paper. I guess this paper is from a couple of years ago now. Um,
Oh yes. Oh
but
yes.
there is this paper on like Arctic wildlife uses extreme methods to save energy, and it's talking about like Arctic animals becoming specialists in saving energy is what it says. And that, I think this is really cool paper. I didn't
Yes.
fully read it, but it is also an example of sort of focusing on just one of these axes instead of sort of collectively considering what kind of relationships and trade-offs do we see if we think of all of this together. um,
Yeah, and then of course that's what I was saying to you before, is to get a more holistic temperature view. If you talk about climate change and so on, we have to take the heat part in too, because animals resist, avoid, or so on, both cold and heat, and then we should have one that looks at all these aspects, right? And
yeah
then, as you said, the interrelationships of species too, which makes it super complicated,
yeah
right? So,
Yeah,
so
so then this is the full paper we were just talking about.
mm,
It's in the Journal of Experimental Biology, partially cut off here, but yeah, and it's specifically looking at like part of how animals, at least in this paper, part of how this bird um, meets the necessary cold resistance requirements is they're saying they sacrifice their immune function for part of the winter. They're like, I only have so much
yes.
energy. I don't have enough energy to like have as high functioning immune system as I might otherwise. I'm going to put some of that energy maybe towards like just body heat generation rather than um,
You because you consume, what they're saying is you consume energy in order to stay immune, right? Um, and
well,
by
yeah,
controlling
they're
your
saying the immune system takes energy. Yeah.
X energy, that's it. So that's very interesting. I didn't know that. That was came as a complete surprise, but it makes sense. Of course, it makes complete sense when you
Hmm.
read it.
Or even like there's a cost like when you're very torpid, like when your body's in
Mm.
hibernation mode, you don't have blood circulating very much, so then you also have reduced immune function. um, and so potentially all of these lead to reduced immune function when you utilize them. But I know that, so because for torpor you have reduced immune function, for cold resistance, like in that paper was just saying, you can have reduced immune function. I know that immune function can also vary with um, time of year for migratory species. So maybe it's not unique to just how cold resistant are you. I think that's another good argument.
However, Georgia, I do remember, I do watch sometimes these extreme um, nature things. Maybe you've watched them too. I shouldn't be alive and all that. I know it's a bit sensationalist, but I watch them because I find it very interesting how human beings are sometimes able to cope under extreme conditions. And what I was very surprised when it came to cold is that some people have survived in extreme colds, also where their temperature went low. I mean, it was not voluntary, but they actually survived extreme temperatures because because of circumstances, their heart rate went down and so on. So obviously we are able to do that also to some extent, right?
Yeah, so I would say that there's a difference between being well, like adapted to do
Mm.
this thing and then just being able to survive this basically injury,
Yes.
or, stressor. Um, like we could survive a disease. That doesn't mean that it's part of like how we function,
Mm. Yeah, right.
if that makes
But
sense.
we have these abilities, which is quite amazing,
Mhm.
actually. Yes.
Yeah, I mean, they say it's like, people that get dunked into frozen water and stuff like that,
Yeah.
like they can be brain dead but survive, but come back from it because they're like kind of like frozen, quote unquote, and then you get revitalized. So Yeah. Kind of wild to think about. Well, oh, we're up on the hour now.
We're already, I cannot believe it.
Yeah.
That's it. Okay. Cryo, yes, that's it. Cryo, exactly.
Yeah. You like cryogenically froze yourself by falling into icy water for a little bit. Yeah. Well,
next week, by the way, we have an interesting topic. So it's going to be, I didn't even tell you that, so I'll take you.
Yeah, I was like, this is news to me. Tell me.
Yeah. Well, it's actually Mike Sears has contacted me again. You remember the one who was talking about all the abilities of birds in high altitudes, right?
Yeah, flying high.
Yes, and next time he wants to talk about flying in general, how hummingbirds and how birds actually fly, the whole mechanism. So that's going to be our next talk. So it's become quite interesting. I'll probably put some of my slow motion videos in there too. And yeah.
Oh, that would be so sweet. Yeah, we need a more visually appealing episode.
So,
I should have pulled up more pictures. I have a lot of pictures of animals with their various winter survival strategies, but
so hummingbirds, of course, fly very different to eagles and so on, and that's what we're going to talk about, right?
They can hover, they can fly backwards, yeah. And
yeah.
to remind our audience, Mike Sears, he has a background in physiology, right? He was a medical doctor in humans. And so he has, a lot of in-depth knowledge in general about like anatomy and things like that. And so he has brought that background to birds, which is really cool. Yeah.
Okay.
Well, goodbye, everyone. Yeah, we'll see you next week on Wednesday as normal this time. Or next week, Wednesday.
And thank you for joining and all your participation. We really appreciate it. Thank you.
Yeah, definitely. Bye, everybody. Yeah.
Bye.
Bye.